Hello, I'm Karl Johannes Balder and I'm a student from the University of Tartu. This work was based on an application developed during my bachelor thesis and was conducted in collaboration with Alexander Nolte from the University of Tartu, Han van der Raa from the University of Mannheim, and Fabrizio Maggi, that was my supervisor in Tartu and is now working at the Free University of Bolzano. This work focuses on the process modeling stage of the business process management lifecycle. Knowledge-intensive processes characterized by several exceptions and allowed paths are suitably represented by declarative process modeling languages, because imperative process models are very rigid, explicitly specifying all allowed behavior so that they become very quickly unreadable when representing processes with a lot of variability. Instead, declarative process models consist of constraints on activities, where all behavior that does not violate the constraints is allowed. In this way, it is easier to represent all the exceptional paths with a small set of rules. Declare is a declarative process modeling language, though probably very few of you can understand its formal or graphical notation. This is actually the response template, meaning that A is eventually followed by B. The formal notation requires knowledge of temporal logic, and the graphical notation is proven to be unintuitive. As you can see, declare is somewhat difficult to model, hindering its business use. This work presents and assesses an analysis toolkit which allows users to model declare constraints by using their own way of expression. In particular, we want to investigate speech recognition for process modeling by interpreting a voice input given by the users and translating it into a set of constraints. This is achieved by adding speech recognition functionality to the modeling component of RuM, a novel desktop application for rule mining. The starting point of the Speech2RuM approach is the voice input, which is recorded and translated into text using speech recognition. Linguistic processing is then used for the automatic extraction of constraints from the text. Multi-perspective augmentation of the constraints is supported, with the possibility of adding data and time perspectives to the recognized declarative constraints. Data and time conditions express more textual fragments rather than full sentences, and their variance is much lower than that of declarative constraints. As such, the tool uses pattern matching to extract conditions instead of grammatical parsing used during constraint generation. The recognized constraints are then collected into a single declare model. The tool also allows for inserting new constraints or modifying existing ones manually, including augmenting them with data and time conditions through interaction with a graphical user interface. For more information about RuM, you can visit rulemining.org. This is a demonstration of the tool.
Process starts when order is received.
I'll use the voice input to create a constraint.
When an order is shipped, an invoice must be sent.
And create the second constraint using the voice input. I can edit the recognized text manually.
Amount is greater than 25 and type is deposit.
And use the voice input to add a data condition.
Between 2 and 12 hours.
As well as a time condition. After implementing the approach, a user evaluation was conducted to understand the feasibility of the approach and to detect issues and ideas that might result from the user feedback. 8 participants were chosen with different knowledge of business process modeling and of modeling declare constraints for differentiation, in order to study how users with different levels of expertise perceive the tool and recognize possible issues and needs. The user evaluation was performed over Skype, with the facilitator guiding the participant and the observer serving in a supporting role. Users were given a scenario and were then asked to form constraints, given pre-constructed sentences and semi-formal descriptions of the constraints using the speech input. For data collection after the test, a follow-up interview was conducted to resolve questions that appeared during the test scenario. Users were also sent a post-survey questionnaire consisting of multi-point Likert scales, with system usability scale being the most important one. For data analysis, an affinity diagram was created associating each issue reported in the user test with a single paper note, resulting in 139 notes over 21 clusters, identified based on different topics. The results of the questionnaire was also factored into the analysis to extract information using the multi-point Likert scale. Compared to the commonly reported average system usability scales score of 68, the average score of 73.13 shows that using speech recognition for declarative process modeling is feasible. But the results also show a clearly present learning curve. In particular, we noticed that all users felt insecure to just use natural sentences and rather aimed to create sentences that they felt the system would understand. This indicates that individuals need to learn how to effectively use speech as a means of modeling constraints, regardless of their previous experience related to business process modeling or Declare. One of the potential improvements to the tool is based on the observation of how participants try to fix potential errors. Participants having low confidence with Declare initially try to edit the visual model, which is not possible in the current version of the tool, while participants more familiar with Declare directly started editing the Declare constraint list. This indicates that to make the tool more user-friendly for non-experts, it would be useful to add a visual editor into the tool. The feedback also allowed us to improve the tool by, for example, adding support for undoing the changes created by the last recording and editing the recorded text directly. Finally, the users thought that the approach would be most useful in mobile scenarios, for example, when working on a smartphone or a tablet. This work presents an interactive approach for taking the vocal input from the user and applying speech recognition and natural language processing to extract multi-perspective declarative process models. The Speech2RuM approach surpasses the state-of-the-art in text-to-constraint transformation by supporting a larger variety of declare templates, as well as permitting their augmentation with data and time conditions. The conducted user evaluation represents the first study into the feasibility of using speech recognition in business process modeling. And the novel input method mitigates the barriers of language bias for Declare by allowing the use of natural language, no longer relying on the graphical notation or formal expressions. Although feasible in practice, the proposed approach was largely recognized to be especially suitable for mobile environments. For this reason, we have integrated the speech recognition mechanism with Declo, a chatbot supporting users in the design of Declare models based on natural language, which represents a valid alternative in the context of desktop applications. For more information about Declo, please attend the demo session, where we will be representing it. The tool could also be developed in the future to recognize other types of process models, for example, procedural process models. Thank you for your attention.